Alright guys, so this video is going to be about net change, and this is an extension of the fundamental theorem of calculus. And by the way, if there is one thing that you need to know for the AP test, it is this lesson. This idea is unbelievably crucial. And this is just the main application of the fundamental theorems. The FTC says this, right? If you integrate some function from a to b, you end up getting the antiderivative at b minus the antiderivative at a. Now the extension to this is if you just integrate a to b of a derivative of f prime of x, you end up getting back to the original function. You just get f of b minus f of a. So what that means is if you integrate some rate from a point A to a point B, you're going to get some kind of final amount minus some kind of initial amount. So just like how integrating f gives you the antiderivative, integrating f prime gives you f, and you just do the final minus initial. So we're going to talk through a couple examples and see just a smattering of some of the examples of real-world problems they'll give you relating to this. Okay, so here's the situation. F prime of x is 3x squared, f is 0, 7, find f of 2. So when you're choosing your a and your b, they're going to give you one point and they're going to ask you to find the other point. Just pick the smaller one to be the a, although it doesn't really matter. So what that's saying is if you integrate 0 to 2 of your f prime of x, that is going to give you f of 2 minus f of 0. Okay, and that setup is the key to all these problems. If you integrate the rate, you're going to get to the original function. That should make sense, right? Because if you integrate f prime, you're going to get to f anyway. So that's the logic behind how you approach these problems. Okay, so how do we do this, right? This is saying integral 0 to 2 of 3x squared equals f of 2 minus, and then this part was given to us as 7. So let's do that integral. So that's saying integral 3x squared, of course, is x cubed going from 0 to 2 equals f of 2 minus 7. Now this is an easy integral to do. This is 8 minus 0 equals f of 2 minus 7. So that tells me f of 2 is equal to 15. Done. Okay, so that's how you do a problem like this. Look for them to give you some kind of initial condition and then some kind of rate. Okay, so let's go back to this. If I just have a net change, so if my IQ is increasing at a rate of TQ plus 1 points per minute, pretty realistic, how much did my IQ change between 0 and 2? So if I want to find like how much my total changed from 0 to 2, that's just the integral 0 to 2 of the rate. So just the integral 0 to 2 of TQ plus 1. Okay. And again, you see the word rate there. That's telling you it's a derivative. We need to integrate it to get to an amount. All right, now, of course, this integral is pretty straightforward to do. We're going to get t to the 4 over 4 plus t going from 0 to 2. So that'll just become, okay, plug in 2 to the 4, 16 over 4. So that's 6 minus 0, which is 6. So my IQ got 6 points better in the 2 minutes it took me to do this problem, which sounds about right. Okay, so let's go with another real-world problem. I have 2 inches of snow in my driveway at time 2. So now we're getting into a problem where we need to write the equations down. I have 2 inches of snow in my driveway at time 0. So f of 0 equals 2. And snow accumulates in my driveway at a rate. There's that keyword rate. That rate is telling me that my rate is 3 root t. So that's saying my f prime is 3 rad t. How much snow is in my driveway at f of 4? So this is a great kind of problem you want to use the individual theorem, the fundamental theorem for it, because they give you a rate, they give you an initial amount, and they ask you about the other one. That's just the kind of problem that the fundamental theorem is great for. So right there, there's your a and your b, right? You have the 0, you have the 4. So it's saying f of 4 minus f of 0 equals integral 0 to 4 of my f prime. So what that's saying is, okay, f of 4 is what we're trying to find. So f of 4 minus 2 is integral 0 to 4 of 3 rad t, also known as integral 0 to 4 of 3t to the 1/2. Okay, the setup is the key, because now actually doing this integral is very straightforward, right? It tells me that f of 4 minus 2 equals, all right, so let's see, that's 3, that's t to the 3/2. We have a 2/3 in front, so those cancel, going from 0 to 4. So that's saying that f of 4 minus 2 equals, let's see, 2t to the 3/2 going from 0 to 4. So one tip I'll give you on a problem like this that can be helpful, just pull the 2 out in front, and then you have 4 to the 3/2 minus 0 to the 3/2. Well, obviously 0 to any power is just 0, but to help you out with the 4 to the 3/2, remember that 4 to the 3/2 is like the square root of 4, that's the 1/2, to the 3rd power. So 2 cubes, that's just 8. So that's saying f of 4 minus 2 is 2 times 8. So that gives me the amount of snow my f of 4 is equal to 18. So we have an indefinite integral, but again, the key is getting to this step. Like that final minus initial is the integral of my rate. That's the crucial part right there. Okay, so let's look at another problem. If the velocity of a potato shot in the air is given by this crazy equation, if the position at time 2 is 50, find the position at 0. Now what we want to remember on these problems is that velocity is the derivative of position. It's x prime. So the velocity is my rate right here. My rate is that 6t squared plus 12t minus 18. So my setup for this problem, again, my a and my b are the 0 and 2 we have here. So my setup here is the x of 2 minus x of 0 is the integral 0 to 2 of my x prime, which is just my velocity equation. So I'm just integrating that 6t squared plus 12t minus 18 dt, and then I'm going from there. Like, solving this is obviously pretty easy. But the setup is the key, is getting to this point. They're recognizing we have this rate, we have this initial condition, and that's how we find the other value here. Okay, so those are some examples where the fundamental theorem is useful. Let's look at a couple more. Let's do a problem like this, where you have one of these f prime graphs. Okay, now one of these parts, I'm asking for 2 parts of this old problem, which the graph might look familiar. It was on a test years. Part A says, at what intervals is f increasing? Well, just a reminder, f increases when my f prime is bigger than 0. So that happens on the interval just from -3 to -2. That's when I'm above the axis here. So that's how you read these graphs. So now part B says, find f of -3 and f of 4. But if we look carefully at this problem, one of the pieces of data they tell you is that f of 0 is 3. That's your initial condition. And that's what we're going to use to set up the fundamental theorem. So let's do these separately. Let's find f of -3, and then let's find f of 4 as 2 separate cases. Okay, so as I go from -3 to 0 of f prime, that's going to give me f of 0 minus f of -3. That's the fundamental theorem. I'm going to get a top minus bottom. And the way I want you to do this is to interpret this integral as an area. When you're integrating f prime, given this f prime graph, read that as an area. Okay, so what's the area of the triangle up top? It's a half times 1 times 1, so that has an area of 1/2. How about the triangle here? It has a base of 2 and a height of 2, so that is 2. Okay, so in terms of that integral, thinking positive minus negative, we have a positive 1/2 and then minus that 2 below. That gives you, and the f of 0 right there is 3. That gives you 3 minus f of -3. Okay, so let's see. We have -3/2 equals 3 minus f of -3. Let's add the f to the other side, add the 3/2. So, f of -3 equals 3 plus 3/2. Okay. I'm going to do the exact same strategy to find f of 4. One little trick here that's going to be a little bit of an issue is I need to find like these areas down in here. Okay, well, how do we find that? Geez, it's not exactly like a semicircle. It's the area around a semicircle. So the way I think we can find that area is, why don't we find the area of the whole rectangle and then subtract the area of the semicircle? Ooh, that should work, right? That'll give me the area around the outside. So if I want to find the area of the rectangle, that's 2 times 4. It's an 2 by 4 rectangle. And then this semicircle has a radius of 2. So that's minus 1/2 times pi times 2 squared. Okay, so that area is going to be 8 minus 2 pi. That red area is 8 minus 2 pi. And again, I found that by finding the area of the whole thing and then just subtracting off the semicircle. Okay, and again, I'll use this same value, the same f of 0. So f of 4 minus f of 0 is still the integral 0 to 4 of f prime. Notice that we need that initial condition. If you don't have that, the problem's impossible. Okay, so f of 4 is what we're trying to find. So f of 4 minus 3 is, okay, and we just said that area was 8 minus 2 pi. So I'll add the 3, so that tells me f of 4 is 11 minus 2 pi. Okay, and that's how we approach the problem. So the fundamental theorem is how we do it. And again, your hint is you have f prime, you have this initial condition, and that's what allows you to find another value on f. Okay, one more type of thing here. You can use it with a table too, and you'll see it in this case. A, estimate g of 4 using a left Riemann sum the intervals in the table. Again, you have this initial value at 0. You have this rate, this g prime. So if I'm going to find g of 4, I'm saying g of 4 minus g of 0 is integral 0 to 4 of g prime. You use x or t, it really doesn't matter. So g of 4 minus 2 equals. And what we're going to do is we don't know how to do this integral. But what you're going to do is we're going to estimate this integral using a Riemann sum, like they said in the problem. So we're going to use a left Riemann sum to estimate this problem. So my intervals here are 0 to 1, 1 to 3, and 3 to 4. So when I do base times height, I'm just kind of replacing this whole integral with a Riemann sum. So base times height, so the first one has a base of 1. I use the height at 0. So 0 to 1, 1 to 3, and 3 to 4. I'm going to circle my left endpoints, use the height there. So that's 1 times f of 0. Sorry, I should use g prime as 0 because that's actually the function. 1 times g prime is 0. And then we have a base of 2, and we're going to use g prime of 1. And then we have a base of 1, we're going to use g prime of 3. So g of 4 minus 2 is equal to, let's see, that's 24 plus 2 times 25 plus 1 times 37. And we can figure this out. You can add 2, whatever, it doesn't matter. Let's get to the next part because I thought this was juicy. Find 0 to 4 of g double prime of x. Now, you might look at this and be like, Boris, how in the deuce are we supposed to integrate g prime without knowing anything about it whatsoever? OMG. But of course, you actually can, right? Because what's the antiderivative of g double prime? It's just g prime. It's g prime of x going from 0 to 4. So if you integrate g double prime, you know you get g prime. That's just telling you what's g prime of 4, what's g prime of 0, and let's subtract. And we know those values from the table. It's there and there. So that's 15 minus 24, which should be, 24, which should be negative 9. So notice the difference here. Here I had an equation for g prime. So I had I didn't have an equation. I just get g prime from g double prime. On the first one, I had to integrate g prime. So I had to use a Riemann sum in order to actually find that integral. Okay, sorry for the long video. This is crucially important. Note, these are all great applications at FTC. Please, please, please bring questions to class, and I'll see you guys soon.